In Level 4, you will decompose composite functions, or break them apart into smaller functions that made up the composite function. In number 8, it says given p of x equals the absolute value of the square root of the quantity x minus 2, find functions f, g, and h such that f of g of h equals p. Remember that f of g of h could also be written like this. And so h of x is the innermost function that was plugged into g, which is the middle function, which is plugged into f. So if we look at the very inside of p of x, the innermost function would be x minus 2. So h of x would be x minus 2. Then x minus 2 was plugged into a radical. So g of x would be the square root of x. And then after x minus 2 was plugged into g of x, giving us the square root of x minus 2, that was then plugged into an absolute value. So f of x, the outermost function, would be the absolute value of x. And then if we check our answer by composing these functions, plugging h into g and g into f, we get, so h into g would be the square root of x minus 2. Plugging that into f, we get the absolute value of that, which is p of x. In the next example, we just have two functions that are composed to give us h of f of x, which equals x squared minus 4x plus 10. F of x is the innermost function, so we need to figure out what happened to f of x that it ended up looking like this. And my guess is that maybe we square it. So if we square f of x, x minus 2 squared, we get x minus 2 times x minus 2, which is x squared minus 4x plus 4. Now that's not exactly the same as h of f of x. But if we add on 6 more, we would get this function. So what we could do is call h of x x squared plus 6. And then when you plug f of x into that, so if we replace x with x minus 2, we get x minus 2 squared plus 6, which is x squared minus 4x plus 4 plus 6, or x squared minus 4x plus 10. So h of x is x squared plus 6.